The Oregon coast, home to many beloved communities and tourist destinations. According to Travel Oregon, nearly 18 million people visit the coast each year, and this industry provides $2.5 billion in revenue to the state. Unfortunately, these communities and destinations are at the forefront of climate change. Rising sea levels and strengthened El Niño southern oscillation patterns are making Oregon's coast more vulnerable and harder for engineers to protect. Today, I will walk through the effects of climate change on sea level rise and their implications for coastal management. To start, we will look at how El Niño and La Niña influence sea level rise and coastal erosion. In the Pacific Northwest, El Niño periods are warmer and drier due to weakened trade winds, and the opposite occurs during a La Niña period, with colder and wetter conditions caused by stronger trade winds. In the Pacific, coastal erosion varies closely with the oscillation between El Niño and La Niña, and future El Niño periods may be amplified due to greenhouse warming. A warming climate causes sea level to rise due to expansion of seawater and melting of land ice. Stronger La Niña events, however, will produce wetter seasons and larger waves. Significant erosion along the Oregon coast has been associated with El Niño and La Niña events, including the 1982-83 El Niño, the 1997-98 El Niño, the 1998-99 La Niña, the 2015-16 El Niño, and the 2020-2021 La Niña. Local sea level rise along the Oregon coast is outpacing uplift factors like plate tectonics and glacial isostatic rebound. Per Dogami, without El Niño or La Niña influence, sea level in Oregon already experiences seasonal changes of 25 centimeters or 0.8 feet. The National Research Council estimates that by 2100, relative sea level rise along the Oregon coast will be 0.64 meters or 2.1 feet. On top of relative sea level rise, strengthened El Niño events can raise sea level during the winter by 10 to 30 centimeters, 4 to 12 inches, according to the National Academy of Sciences, or up to 60 centimeters, 2 feet, according to Dogami. By 2100, the mean shoreline position will shift landward by a total of 2 meters, 6.6 feet, in response to sea level rise and heightened El Niño southern oscillation, per Dogami. Mitigation of surface hazards, like landslides, will become increasingly difficult with the rising sea level and increased coastal erosion. Fortunately, risks to public beaches and parks have historically and are currently being assessed by state agencies, like we saw with Speaker Bill Burns in the Ecola State Park Risk Assessment. Under the 1972 Federal Coastal Zone Management Act, coastal states are required to have a coastal management program or department. Oregon created the Department of Land Conservation and Development, or the DLCD, in response to this act. The DLCD created regulations on shoreline armoring and hard engineering structures, as they can lead to lowering of the beach profile, resulting in the loss of public access to Oregon's beaches. The DLCD's Goal 18 states, "Permits for beachfront protective structures shall be issued only where development existed on January 1, 1977. Beachfront protective structures are defined as fixed structures with the purpose of redirecting wave energy and minimizing coastal erosion to a development." One example of a beachfront protective structure seen along the Oregon coast are seawalls. Seawalls inhibit sand replenishment at their location and redirect wave energy and erosion downshore. Shoreline armoring practices like seawalls and sandbags also need costly maintenance and can often become eyesores for visitors over time. The enactment of Goal 18 has limited the use of hard engineering practices and forces engineers to shift towards soft engineering or engineering with nature practices. One example of an adapted design presented in class was PLI Systems' use of in-situ grout injections to strengthen existing materials near Glenadin Beach. Other approaches that consider land use, infrastructure, and the community are the future of coastal engineering. The According to a study done in 2025, coastal management and engineering research are increasing alongside soft engineering approaches in general. Today, we looked at the effects of climate change on sea level rise and its implications for coastal management. As a final call to action inspired by speaker Nick Legg, we as engineers and scientists must be prepared for climate change and have plans in place for mitigating increasing hazards. Thank you.